Picking up where we left off, we are now going to go from a percent to a decimal. So our author tells us to type these in a calculator. I already showed you that, right? We typed in the 12 or 100 and we got our nice decimal. You may have noticed that when we did that, for example, so we got 12 over 100 here, but if we had typed 12 over 100 in the calculator, we would have got 0.12 or 0.12. Same thing here, if we'd had 72%. If we had typed 72 over 100 in our calculator, we would have gotten 0.72 as our decimal. So it turns out, noticing if we noticed where the decimal place originally was in both of these percentages, it was to the far right of the number, and then it ended up being 2 places to the left of the number once we converted that percentage to a decimal every single time. Turns out that is always true. That's what happens when you divide by 100. It moves the decimal place 2 places to the left. So that's what we are to fill in here. To convert a percent to a decimal, drop the percent sign, that's important, and move the decimal point 2 places to the left. So let's demonstrate that here. Here we've got 41%. So what we would do is note where is the decimal place. It's right here. If you don't see a decimal place, it's to the far right of the number. We're now going to move it to the right, to the left 2 decimal places, and we get 0.41. Now, I will always try to remember to write a 0 in front of the decimal place, but you know what? Mathematically speaking, 0.41 is the same thing as 0.41. Okay? You will find that in ALEX, they will say, oh, we often write it with a 0 as opposed to writing this. There's good arguments. It helps you keep track that this is a decimal. You wouldn't mistake this number as 41, where you might mistake this number as 41 with having the 0 in front. Who knows? Okay, letter B. Here we have a decimal within the percentage, totally fine. We're still moving the decimal place 2 places to the left. We encounter a problem, right? There's a space where there's no number. Put a 0 in as a filler, and you get 0.067. That's the decimal version of that percent. And then finally C, 120%. Here we go, move it 2 places, we get 1.2 as a decimal. Now, here's the thing. These decimal versions of the percent, these are the numbers we use in calculations. If we're multiplying, dividing, adding, subtracting, we want decimals. Unless all of our numbers in percents, then you can add and subtract and multiply and divide. Okay, so now our author's like, all right, what if we want to go backwards? What if we have a decimal and we want to turn it into a percent? Well, he leads us through maybe this might be a little confusing to you. The opposite of moving the decimal 2 places to the left is moving the decimal 2 places to the right. The opposite of dropping the percent sign is adding in a percent sign, putting it there. So what's the procedure for converting these decimals to percents? Well, if I have 0.34, I'm going to move the decimal 2 places to the right and add in a percentage symbol. Now, I would much rather you know what is actually happening here. If we're moving 2 places to the right, what operation is occurring? Well, if you think about what was happening before, we were dividing by 100. So the inverse of dividing by 100 is multiplying by 100. And that's exactly what's happening here. Multiplying by 100 has the effect of moving a decimal place 2 places to the right. All right, last one, 1.658. Multiply by 100, that's equivalent to 165.8%. And there you have it. You should now know how to go from a percent to a decimal and a decimal to a percent. Technically, you should also know how to go from a percent to a fraction. Turns out that's not super useful because we can use, in many cases, using a decimal is easier. It's certainly less typing, and it's less difficult to make mistakes in how you type it in a calculator if you use a decimal as opposed to a fraction. Okay, on page 8, there's a really nice example problem that I encourage you to read through and work through, and it's how to calculate a percent of something. And then there's a second example problem that I really encourage you to read through, and that is how to calculate an original sale price given a discount or original price. So take a look at that. We're going to do some more practice problems here in the videos later for you to get some more help with that if you don't quite understand what's going on in those example problems. Also, if you want me to work this out, send me an email and I'll work it out for you in class or otherwise. So now our author says, hey, the number, if we want to find a percentage, we use division, right? So one of the things we're talking about here is a part to a whole. That's really what a percentage is, another kind of definition of a percentage. So a percent of something means a part divided by a whole. Now we need to be careful. This definition of whole may not be the actual total amount. It could be a part to a part. And that's a very useful thing, particularly in this world of COVID, talking about percent infected. So what's the whole? Is the whole all folks that are vaccinated, or is it all people total, both vaccinated and unvaccinated, and looking at what percent of either of those groups is being infected? That's an important question to ask to see if our vaccines are effective. This is a much less controversial question. It just says there are 32 teams in the National Football League. So only 12 of those teams ever make it to a playoff based on their how many games they win, etc. So what percentage of the total teams make it to the playoff? Notice the way they asked it. What percentage of teams make the playoff? So this is the part, and this is the whole, the 32, based on our definition. So we're going to write this as 12 over 32. That's the fractional version. To convert that to a percent, we would multiply this by 100, and that would get us a percent. But there's no decimal place in this fraction. So what our author says is, let's write this as a fraction and then write this answer in decimal form, and then this calculation becomes much easier. So instead of trying to do that in my head, I'm just going to do 12 divided by 32, and there I get 0.375. So that's the decimal version of a percent. Well, now, if I multiply this by 100 to convert our fraction, which was converted to a decimal, into a percent, I can just move the decimal place 2 places to the right, and I get 37.5%. You know what's crazy? That's the same number. No, it's not. Oh, yeah, it is. That's the same number we were asked to convert to a decimal way back here. Remember, that was 0.035 when I typed that into decimals. Okay, did I get ahead of myself? I did. So it says divide the number of teams that make up playoffs by the total number of teams. That's this 0.073. And then number 9 says, hey, what's the percent that make it to the playoff? So only 37.5% are ever going to make it to the playoffs.